Ritkat, that it was continued our meeting. TC critical time, someone has written that Sonali Patil, only she is replying, but others are doing, I don't know. That 2.019 critical time 2.019. Anybody else? Anything else answer? Anybody else? Anything else answer is there? Two students have written answer. Maybe one of them is Sonali Patil. Okay, tell me the answer. Shall we proceed with the existing answer? What Sonali Patil has mentioned? आप लोगों ने तो सॉल्व नहीं किया होगा, तो बेहतर है सोनाली पाटिल का आंसर कॉपी कर लो आप लोग. Okay, TC. Now you can determine DC. DC is equal to, what is the formula to determine the DC? I will share a formula with you for the DC. It is K upon R into L naught into bracket 10 raised to minus K into TC. Okay, it's a very interesting topic. You people are not taking interest, and then how we can explain it? Okay, DC is equal to, write down please. What is the value of K? Value of K is 0.1. Value of R is 0.3 into L naught. L naught you have calculated, and that value of L naught is 38.78 into bracket 10 raised to minus K is the 0.1 again, and value of TC recently you have calculated, and that value is 2.019. Is it? Then you can calculate DC. Calculate DC and tell me the answer. Priyanka Pulal's answer is also same as 2.019 for the TC. Now Priyanka, go for the DC. Yes, Sonali has calculated for the DC also, and that answer is 8.1912. 8.121 milligram per liter. Others, please check answer. DC, critical dissolved oxygen deficient. Okay, if I will ask you to draw the graph with the figures, you should be able to draw it. Is the same answer from others? Eight point 8.121 is the same answer. Priyanka had given answer, same answer. Okay, thank you. Now what will turn once again towards your question. I will share that question only file. Find the critical dissolved oxygen deficient and dissolved oxygen in the river after 1 day. Critical dissolved oxygen, we have determined that it is 8.121 milligram per liter. Now the next question is dissolved oxygen in the river after 1 day. How to calculate? How to calculate? Someone please tell me, or shall I display the formula? Okay, I will. X is equal to TC into V. Is it? Now TC is the critical time. It is given to you. What is asked to determine? Let me check once again. Question is to find the critical dissolved oxygen deficit and DO in the river after 1 day. No, it is asked to determine the DO after 1 day. So usual process, by that you can write down about after the at the 1 day. Is it? Are you getting what is to be written? Here you need to apply the formula that Streeter-Phelps equation dt is equal to. Am I right? dt is equal to dt, t for time. What is the time? It is asked 1. So d1 is equal to k into L naught. Value of k is the 0.1 into L naught. Okay, I will display the formula first. Maybe you need this. What is displayed now? I think this formula is required, need to write. Yeah, this one. dt is equal to k into L naught upon R minus k into bracket 10 raised to minus k into t minus 10 raised to minus R into t plus d naught into 10 raised to minus R into t. So write down this formula and then write down the values. dt is equal to dt, t stands for 1 day. After 1 day, it is asked in the question after 1 day. What is the value of k? Value of k is 0.1. Value of R is 0.31. L naught you have calculated 38.78. So 0.1 into 38.78 upon 0.3 minus 0.1 into bracket 10 raised to minus k. What is the value of k? Value of k is again 0.1 into t. What value will take here? Value of t? Value of t will be 1. Is it? Minus 10 raised to minus 0.3 into 1. Bracket complete plus d naught you have calculated 2.976. D naught you have calculated 2.976 into 10 raised to minus R. Value of R is a 0.3 into T, small t. Value of small t is 1 into 1. Now tell me the value of dt. Value of dt, please. I hear your question is over. dt answer calculated by Sonali. It is 7.176. 7.176 milligram per liter. Is there any another answer? Is there any other answer? Aditya, I am not happy with you. Why you are not contributing today? Ever you used to contribute. Aditya Mahajan, is there any problem? Amol Pawar. Okay, Priyanka's answer is 7.15. So maybe the difference between digits only. So the final answer is 7.16, you can say, milligram per liter for the critical dissolved oxygen deficit. Okay. I will go back to the page. Back to the question now. Okay, here now all the answers are with us. Now we can see a simple diagram I will try to draw. I'm not going to the college, so I don't have board to show you. So this will be the saturation level. Okay, what is the saturation level of dissolved oxygen? It is 8.22. It is 8.22. Okay, then initial dissolved oxygen deficit, the river stream dissolved oxygen of stream is 6 point. So I will keep this much gap and I will start drawing here. It is the initial dissolved oxygen deficit, then it will start dropping down and will reach to the critical dissolved oxygen deficit and will go back. Okay, so what is the critical dissolved oxygen deficit we have calculated? It is 8 point. What is this? It is the difference between these two. It is DC, and that DC is nothing but it is 8.121. 8.121. Okay, then dissolved oxygen deficit at time t at 1 day. After 1 day, suppose here is the 0th day, you can say here is the 1 day. So at 1 day, what is the dissolved oxygen deficit? That is D1. I can say D1 is equal to 7.176 or 7.15. Okay, whatever may be the answer. Is that fine? Then critical dissolved oxygen time. So here the time required to reach up to this portion, up to this. One second. Okay. What I was telling you. Oops. Time required to reach the water up to this spot is the critical dissolved oxygen, critical time TC, and that also we have determined, that is 2.019. Okay, so this way you can draw the profile of the as an answer of your question. Okay, now one more solved example I will explain here. It is solved and written here. So we will just discuss that. Just little change is there, and that we will discuss, and then we'll stop on this topic, and then part 2 of this chapter we will start. Okay, just see here, pay attention, full attention, you please pay, because it again here is the little change. So little hard, we can say. It is not hard, but little not easy, I can say. Okay, write down. No, sorry, if you want to write down, you please write down this simultaneously. A city discharges 20,000. For GATE exam also, the maximum question will be there. Almost 1 or 2 question will be there from BOD, and simultaneously on this topic also. Consequent, the question will be there on this topic. So those who are preparing GATE, they should understand this concept properly, and they can write it properly. Okay. Example, write down: a city discharges 20,000 meter cube per day of sewage into a river whose rate of flow is 0.7 meter cube per second. Determine DO deficit profile for 100 kilometer from the following data. So please copy this question, then I will explain how it is solved. So it is solved example. I have placed on the Zoom. So we will discuss simultaneously. You can keep on writing, please. Okay, guys, what is the difference between earlier example and this example? What is the difference between this example and earlier example? A city discharges 20,000 meter cube per day of sewage into a river whose rate of flow is 0.7 meter cube per second. Determine DO deficit profile for 100 kilometer from the following data. I have shown to you how to draw the profile, or simply you can write it in a tabular form, the profile after every 10 kilometer, after 20 kilometer, you can simply go for that. Okay. Now the data is given to you for river as well as sewage effluent from STP. STP stands for the sewage treatment plant. Then BOD at 20 degrees Celsius is given to you 3.4 milligram per liter for river, and for effluent or the wastewater it is at 20 degrees Celsius, 45 milligram per liter. Then here temperature difference is given. So you need to find out the temperature mix also. The way you determined DOD mix and DO mix in earlier two example, you need to find out the temperature mix also. Okay, that is the difference in this example as compared to the earlier examples. Okay, dissolved oxygen of river is given to you 8.21 and dissolved oxygen of sewage is given to you 2.0 milligram per liter. Velocity of mix is given to you 0.25 meter per second. R dash that is equal to given to you 0.4, K dash is given to you 0.23. Not only the temperature difference is given and then you can find out just temperature mix and then you can solve the example. It is not like this. It matters further on various parameters, or especially you can say a rate constant, deoxygenation rate constant and reoxygenation rate constant. Sorry, a reoxygenation rate constant 0.4. It is given as a standard for the 20 degrees Celsius temperature, or K dash is also given to you as at 20 degrees Celsius. But here is the temperature difference and that you need to find out. Okay. Now you can find out, determine. Simply you can solve the way you have solved earlier example. Note down the given data. If it is given in a tabular form, no need to copy it because it's simply to, you can take the values. Then saturation value, it was not mentioned, I think above. It has to be mentioned in the question itself. Saturation value of dissolved oxygen of river. Riverचा temperature किती आहे? 20 degrees Celsius, 23 degrees Celsius. 23.74 degrees Celsius is equal to 8.57. It is given in a, it has to be mentioned above actually. Okay, let it be. Then go ahead. River discharge. River discharge is given to you 0.7 meter cube per second. And sewage discharge is given to you in a meter cube per day. So you can convert it into meter cube per second by dividing 24 by 60 into 16. Okay, guys. BOD mix you can determine by this formula. DO mix you can determine, and the way you have determined BOD mix and DO mix, you can determine temperature mix. Are you there? Is there any difficult to understand? No, up to here it is, there is no difficulty. Sorry, if you have not copied, please copy it. I will give you 2 minutes to copy. Okay, have you done? Now the ultimate BOD, that is Y5U. We have given the notation Y5U, or it is nothing but the LT. That also equation we have solved in the first chapter. Okay. So that Y5U is equal to L naught into bracket 1 minus e raised to minus k into t. Okay. What is the value of Y5U? It is calculated 13.72 is equal to L naught into bracket 1 minus e raised to minus k into t. What is the k? Value of k is given to you. It is 0.23 and into t, definitely the t will be 5 because we are determining, we have written the formula for Y5. So from that L naught you can calculate as it will be 20.08 milligram per liter. If you are finding something else answer than this, you can tell me. We will discuss. Okay. Then the next one, initial dissolved oxygen deficit. That is also simple to calculate. What is the saturation level of dissolved oxygen deficit? 8.57. Is it 8.57 minus 6.66? The dissolved oxygen deficit of, sorry, DO mix 6.66. Actual dissolved oxygen level of stream is the 6.66 and saturation level of dissolved oxygen of stream is the 8.57. So you can find out this initial dissolved oxygen deficit is equal, D naught is equal to 8.57 minus 6.66 is equal to 1.91 milligram per liter as the initial dissolved oxygen deficit D naught. Okay. Then we'll turn towards the deoxygenation and reoxygenation coefficients at 23.74 degrees Celsius temperature. Why 23.74 degrees Celsius temperature? Because the mixed temperature is 23.74 degrees Celsius and actual temperature of river is 23 degrees Celsius and sewage temperature is 26 degrees Celsius temperature. So there is a temperature difference between two different liquids. So we determined the temperature mix, that is 23.74 degrees Celsius. So that condition is at this respective temperature. So for this temperature, you need to find out R and K. Are you getting? I will try to explain once again. In earlier example, the temperature difference of river and stream was not given. Same temperature we have assumed that 20 degrees Celsius. So we have not worked out on the temperature front. But now we need to work out on the temperature front. Why? Because the river temperature is given as a 23 degrees Celsius and sewage temperature is given to you as a 26 degrees Celsius temperature. Okay. And the change in temperature affects on, change in temperature will affect on the value of deoxygenation rate and reoxygenation rate that we have discussed when we were discussing theoretical part of this chapter. Is it? So it, how the value of R and how the value of K will change, that we will see. So first of all, write down deoxygenation and reoxygenation coefficients at 23.74 degrees Celsius temperature. And then you know the formula to determine the value of R and value of K at the specific temperature. Okay. Now, first of all, we will calculate, here it is calculated RT. RT is equal to R20 into theta raised to T minus 20. Okay. RT is given to you, sorry, R20 is given to you 0.40. R is given to you 0.40. Okay. R dash is given, that means it is a log to the base E, not log to the base 10. I told you in the last lecture, if it is mentioned specifically, then you can go with whatever the conditions given. And if it is not mentioned specifically, you should understand that is given to the base 10. So here it is mentioned R dash. So you should go with that is the to the base E. Okay. Now RT is equal to R20 into theta raised to T minus 20. RT in the sense कुठल्या टेम्परेचरला काढायचं आपल्याला? We need to find out at the temperature 23.74 degrees Celsius. So here it is written RT as a 23.74 degrees Celsius is equal to R20. Value of R20 is given to you 0.40 into theta. Okay, while writing the theoretical part or discussing the theoretical part, I told you value of theta at the 20 degrees Celsius to 40 degrees Celsius, in that range, you can take 1.016. Is it? So here it is taken 1.016 raised to T minus 20. What is the T? T is the temperature, current temperature. So current temperature is 23.74 minus 20 is the standard temperature minus 20. So when you will calculate that R 23.74, you will get the answer 0.424 per day. But here it is not calculated the value of K dash. Sorry, K 23.74. The way it is calculated for R 23.74, you need to find out the value for K 23.74. K 23. I'm not able to write with this tool. K 23.74 is equal to K20. What is the value of K20? Value of K20 will be as it is given above. It is given above, no? It is given 0.20. It is given, sorry, 0.23. It is given 0.23. So you can take as a value is equal to 0.23 into bracket theta raised to T minus 20. Theta at 20 to 40 degrees Celsius. It is in the range of 20 to 40 degrees Celsius. What is the value I told you? While calculating K, you can take the value of theta as 1.056. The value of theta you can take 1.056. Am I right? Or you may have written in your notebook that you can see. Raised to 23.74 minus 20. Calculate it and tell me the value of K. 23.74 is equal to. Tell me the answer. येते का आन्सर काय? खरा कॅल्क्युलेट आणि आन्सर सांगा प्लीज. प्लीज प्लीज म्हणून तर माझं तोंड दुखायला लागलं, पण तुम्हाला काही त्याचा फरक नाही पडत है ना. You became habitual with these teachers and requesting, and you are doing whatever you want. कोणी कॅल्क्युलेट करते का सांगू मीच? कोणी कॅल्क्युलेट करते का मीच सांगू? हे तर हो किंवा नाही बोलत, चला यार. Okay. See here. If you don't want to tell, I will tell you. It is calculated further. It may be the answer. See here, k value of k is determined at 0.273. Okay, k 23.74 will come as a 0.2733. Now critical time Tc you can determine the way we have determined in the earlier example, 1 upon r dash minus k dash into log to the base e into r dash upon k dash into bracket 1 minus do. It is not do, it is d naught. It should be d naught. There is a printing mistake. D naught into bracket 1 minus k dash upon k dash into L naught. Okay. So write down values. 1 upon value of r dash you have calculated, that is 0.424 minus value of k dash is 0.273 log to the base e. Same values of r and k. Then 1 minus value of d naught you have calculated 1.91 above into value of r minus r dash minus k dash upon k dash into L naught. Value of L naught you have calculated, that is 20.08. From that you can determine critical time Tc in a days, and that is 2.557 days. Now the next step is to determine the critical dissolved oxygen deficit DC. Critical dissolved oxygen deficit DC is equal to k dash upon r dash into L naught into e raised to minus k dash into Tc. Tc here, it is the, why we have taken Tc? Because here it is a critical dissolved oxygen time. Critical dissolved oxygen. So if time here is the critical dissolved oxygen time. So here also it will come the Tc. Okay. Now I will erase all these things and then we'll proceed. Okay. Then critical dissolved oxygen deficit is equal to this you have determined as value of r and k, L naught, value of k dash again, and value of Tc. Tc you have determined here 2.557. From that DC you can determine as a 6.432 milligram per liter. Okay. Now the next question is being asked in that to draw the profile, to determine the profile. What is the determine dissolved oxygen deficit profile for